In this video, we will see the comparison table for silicon and germanium, and based on that, we will discuss some questions. Comparison table for silicon and germanium is shown now. The properties are listed here, and this property is compared with silicon and germanium. Atomic number for the silicon it is 14, and for the germanium it is 32. If the atomic weight is compared for silicon, it is 28.1. For germanium, it is 72.6. Density of silicon is 2330 kg per meter cube, and for germanium, the density will be 5320 kg per meter cube. And dielectric constant, if it is discussed, for silicon it is 12, and for germanium it is 16. Atoms per meter cube, that is for silicon it is 5.0 into 10 power 28. For germanium it will be 4.4 into 10 power 28. Energy band gap at 0 Kelvin. For silicon it is 1.21 electron volt. For germanium it will be 0.785 electron volt. Energy band gap at 300 Kelvin. For silicon it is 1.12 electron volt. For germanium it is 0.72 electron volt. Intrinsic concentration, that is Ni at 300 Kelvin. For silicon it will be 1.5 into 10 power 16 per meter cube, and for germanium it is 2.5 into 10 power 19 per meter cube. This intrinsic concentration sometimes expressed in terms of centimeter cube also. So we know that 1 centimeter will be 10 power minus 2 meter, or 1 meter will be 10 power 2 centimeter. Okay, if it is centimeter square, it will be 10 power minus 4 meter square, and for centimeter cube it will be 10 power minus 6 meter cube. Suppose you want to convert meter cube to a centimeter, it will be 10 power 6 centimeter cube, and for meter square it will be 10 power 4 centimeter square, and for meter it will be 10 power 2 centimeter. Okay, using this conversion, for intrinsic concentration of silicon, 1.5 into 10 power 16 per meter cube will be equivalent to 1.5 into 10 power 10 per centimeter cube, because 1.5 into 10 power 16, instead of this meter cube, if you express as 10 power 6 centimeter cube, the next step will be 1.5 into 10 power 16. This denominator 10 power 6 will go up, so it will become minus 6. So the answer will be 1.5 into 10 power 10 per centimeter cube. So intrinsic concentration of silicon you can also express as 1.5 into 10 power 10 per centimeter cube, and for germanium it will be 1.5 into 10 power 13 per centimeter cube. Okay, hope you got this point. And intrinsic resistivity at 300 Kelvin, for silicon it is 2300 ohm meter, and for germanium it is 0.45 ohm meter. This intrinsic resistivity also sometimes expressed in terms of ohm centimeter. So if it is expressed in ohm centimeter, you can add 2 zeros extra. That is, for 1 meter it will be 100 centimeter. Using this concept, you can write it as 2300 and 00 ohm centimeter. This is for silicon, and for germanium it will be 45 ohm centimeter. Okay, so if it is compared with the intrinsic resistivity, silicon having more intrinsic resistivity. Okay, electron mobility, if it is compared, that is mu e, electron mobility, if it is compared, silicon is having 0.13 meter square per volt second, and for germanium we are having 0.38 meter square per volt second. This electron mobility sometimes expressed in terms of centimeter square per volt second. Okay, so if it is expressed in centimeter square per volt second, you have to write it as 1300 centimeter square per volt second, and for germanium it will be 3800 centimeter square per volt second. Hole mobility, if it is discussed, For silicon it will be 0.05 meter square per volt second, and for germanium it is 0.18 meter square per volt second. If it is expressed in terms of centimeter square per volt second, it will be 500 centimeter square per volt second, and for germanium it will be 1800 centimeter square per volt second. The next property is diffusion constant for electron. Diffusion constant for electron, if it is discussed, for silicon it will be 0.0034 meter square per second, and for germanium it is 0.0099 meter square per second. If it is expressed in terms of centimeter square per second, it will be 34 for silicon and 99 centimeter square per second for germanium. Diffusion constant for hole, it will be for silicon 0.0013 meter square per second, and for germanium it is 0.0047 meter square per second. If it is expressed in terms of centimeter square per second, it will be 13 centimeter square per second for silicon and 47 centimeter square per second for germanium. These are the properties that we can compare silicon and germanium, and two more important property, that is cut-in voltage and the temperature range. So cut-in voltage you can add in the table. Cut-in voltage for the silicon it will be 0.7 volt, and for germanium it is 0.3 volt. Sometimes it is expressed as 0.6 to 0.7 volt. Here for germanium it will be 0.2 to 0.3 volt. Okay. The temperature range if it is discussed, for silicon it will be for the temperature range of operation. For temperature range of operation for silicon it will be minus 60 degrees Celsius to plus 175 degrees Celsius. For germanium it will be minus 60 degrees Celsius to plus 75 degrees Celsius. So we can operate silicon at higher temperature compared to the germanium. We have discussed the comparison table of silicon and germanium, and based on this comparison table we will see some questions. The first question, the band gap of silicon at 300 Kelvin is. In this question, band gap of silicon at 300 Kelvin is asked. The correct option will be option B, 1.10 electron volt. So band gap of silicon at 300 Kelvin will be 1.10 electron volt. Next question, what is the approximate mobility of holes in germanium at room temperature? In this question, approximate mobility of holes in germanium at room temperature is asked. We will check whether we have discussed this point or not. The hole mobility of germanium, it is 0.18 meter square per volt second, or in terms of centimeter square per volt second it will be 1800 centimeter square per volt second. So the correct answer for this question will be option C, 1800 centimeter square per volt second. The next question, temperature range of germanium transistors. So temperature range of germanium transistor, if it is discussed, the temperature range for germanium transistor will be option B, minus 65 degrees Celsius to plus 75 degrees Celsius. In the temperature range of germanium and silicon, for the germanium it will be minus 60 degrees Celsius to plus 75 degrees Celsius. This is very important, plus 75 degrees Celsius. And for the silicon it is minus 60 degrees Celsius to plus 175 degrees Celsius. This is also very important. So for this question they have asked temperature range of germanium transistor. For this question the correct option will be option B, minus 65 degrees Celsius to plus 75 degrees Celsius. Next question, for germanium the forbidden energy gap is, so energy band gap, forbidden energy band gap, everything is same. For the germanium it is asked, so for the germanium it will be option D, 0.7 electron volt. Final question for our discussion, the number of proton in silicon atom are. So they have asked the number of protons in, we have already discussed the number of protons is same as atomic number. Number of proton is same as atomic number. So the atomic number for the silicon atom is 14. Correct option for this question will be option B 14. Thanks for watching this video.